dimensional genus strictly smaller than the concordance genus? And the answer is yes. This answer is given by Kazan and also Nakanishi independently. And I couldn't find Kazan's work, so according to Nakanishi, so this is his theorem. So for any given n, there exists some knot K with genus, the four-dimensional genus of K is equal to M, but the concordance genus is strictly bigger than M. So, and then these knots are actually the knots with this property here. So this is for the armable genus case. So how about the Crosscap number? And we ask this question. So let us see the Crosscap number. And we know in case K is less knot, and we also have the four-dimensional Crosscap number is equal to the concordance Crosscap number is equal to 0. And how to say? Yes, and gamma of K is also normally it's not 0. So only we define only the so what is it? In case of K M naught, gamma of K is equal to 0. So we know that this is true. So question is, so whether these two are the same thing, namely whether there exists some knot K with gamma star of K strictly smaller than gamma C of K. So this is parallel to this question, and the answer is again affirmative. And here is the theorem. There exists infinitely many knots K with a four-dimensional Crosscap number is equal to 1, but gamma C concordance Crosscap number and strictly bigger than 1. So then we know that so this K other K satisfy this inequality, right? Are there any questions? It's okay, right? Okay. So actually, we constructed two families of knots. So among the two families of knots, there are knots satisfy this property. Okay, and today I will only introduce one family. I will draw the picture here. And we denote this knot K and P. And here P is an odd number. So this P, so we have two bands here, right? And this P means we have this box. This box here means that we have P half twist between these two bands. And here 2N, and here we have two strings. Two threads, and 2N means that we have, so this box means we have 2N half twist between these two strings, okay? And So actually this knot is, this knot is actually the pretzel knot with 3 tassels. P4 minus P, P2N minus P. And so there's a result by Ichihara and Mizushima, and they prove the cross-cap number of pretzel knots with 3 tassels. No, not only 3 tassels. They determined all the cross-cap number for the pretzel knots. And so according to their result, so this family of knots, so we know gamma of K and P is equal to 3. And we have claim 1. Gamma star of K and P is equal to 1. So think about this part. 1, 2, 3, 4. And by adding such a half-twisted bands here, and by doing surgery along this half-twisted band, and we have this picture. And this is actually trivial. And then, so by doing this surgery, our knot KMP there, it becomes this kind of knot. So just for easier, like this. And here I will just draw 2 here. Here, right? And you can see this is actually a ribbon knot. And this is a ribbon knot. And therefore, it is a slice knot. And so this knot actually bound a slice disc. And now we have this slice disc and we have this half-twist band. And the union of these two give us a Medus band. So we have a mapping command bounding the knot K and P. And therefore, we know this is true. And now, I want to prove that infinitely many knots of this kind of this family, they are actually have concordance crosscap number bigger than 1. So namely, actually I give a necessary condition of for the KMP knot to be to have concordance crosscap number 1, and unnecessary condition of gamma KMP is equal to 1. Gamma C, sorry. And so it's here. If gamma C of KMP is equal to 1, then P squared, there exists odd number L. P squared minus A10 is equal to L squared in case P squared is bigger than 0, and otherwise and P squared in this case. And so this is a necessary condition for KMP to the concordance gamma C of KMP to be 1. And it's not hard to see. Actually, there are infinitely many MP, the pair of MP, such that this condition doesn't hold. And for example, and in case P is equal to 1, N is equal to 2, and we have knot K1, 2, so it is actually the pretzel knot 313, and in Rolfsen's knot table, it is noted by 74. And this knot is actually a knot which doesn't hold this condition, and gamma, we know that gamma C74